Hello and welcome back to Precalculus. This is section 9.3 on parabola. Now you already know most about parabola. The form that you have seen before as y equal ax squared plus bx plus c, or the form of y equals a x minus h squared plus k, uh, were the forms where for positive a you had parabola open up, and for negative a parabola open down. Now clearly a is not allowed to be 0, because if a was 0 that would kill the x squared term, and then you just have a linear line. You don't have a parabola anymore. So this is something that you already covered back in chapter 2. I believe section 2.2 was on the quadratic function, which is called a parabola. Today we're also going to see sideways parabolas that actually have y squared in them. And before we jump into this, I'm going to again, one more time, note that this h comma k is the vertex, and that you can use completing the square to move one form into the other form. Another way, right, if you have the upper equation, you can find the vertex by calculating the x coordinate as what was the b negative b over 2a. Ha, my head my brain had the twitch of couldn't remember it. So negative b over 2a, and when you calculate f of negative b over 2a, you would come up with the k. So hk can be computed using ABC form as well. Now we did say that you can transfer that form into the standard form by use of completing the square. So all of that stuff you guys covered before in the in chapter 2. So now we want to um, cover a little bit more about this parabola. And for this uh, sideways equations and so there are different formulas that you can consider for the parabola. So the standard form of the equation of the parabola with the vertex at the origin, so the standard form of the parabola with vertex at origin, meaning 0, 0, is given as y squared is equal to 4px, or x squared is equal to 4py. So yeah, I know, yet another way, right, to write good old x squared. But there are some um, advantages to writing this this way. So what we have now, because again we are taking a deeper look into parabola as the just like we did for ellipse and hyperbola, you're going to learn this new line called the Directrix, which is actually used to describe the parabola, and we can figure out what the meaning of all of this is. So if I draw parabola, at the origin, there is a line called Directrix, sorry, which is p units away from the line that contains the vertex, and there is the line, right, for that. There is also focus, which is the same distance away, focus f, which is also p units away. Now, parabola is defined as like this: the distance, call it d1, from the directrix to the parabola. Now, I see that my parabola is terrible, because that distance should be the same as this distance here. So d1 needs to be the same as d2. Now, obviously, the drawing that I have is terrible, so these two distances don't look the same on my picture. So probably let me try and move this directrix uh, closer and the focal point closer, so this should look a little bit better. So I'm going to move this here, and directrix is going to be this line. So let's see now. You have a p over here and p over here. That's the p that shows up in your equation. And let's say this, it's not better, but it's a little bit better, I guess. So again, d1 and d2, and those two should be the same length. So this parabola is supposed to, I haven't tried to fix that as well, whatever. It should go out more like this. So now let's see if I do, let's say this. Okay, now it looks better. So call this d1, call this d2, and then they are closer together. Now all of this is going to be the same, just sideways, for the y-squared graph. The reason why I drew this one first is the one that you are familiar with. Now, if I draw the same thing for the other side, we still have our x and y coordinate system. I'm going to now just draw wide. There we go. So now I'm going to draw directrix and focal point here, and just pick a value somewhere, say d1 equals to d2, and it has my p, and here's my p, and this is the focal point, and again this is directrix line. So when you have the parabola given to you, now this one is centered obviously at the origin, then you can calculate the distance for the directrix line and calculate the distance for the focus, and you can find where those are. Again, lenses, satellite dishes, and all other things, right? Because all of those things converge at the focus point, so you want to position the stuff there. So let's just come up with, I guess, two examples, one vertical, one horizontal, and then go and see what happens when it shifts away from the origin. So let's say that you have your good old y equals 6x squared, right? So this is at the origin. Remember, if I put plus 3, it's going to go 3 up. It's not at the origin anymore. So this is where we are now. And when you compare this to y equals 4px squared, you see that 6 is equal to 4p, from where p, right, is equal to 6 over 4, which is 3/2. So to graph this parabola, we are going to write with all of its features. We know that the vertex is at the origin, which is 0, 0. Now, directrix is going to be 3/2 down. 3/2 down is going to be 1.5, right? So we're going to draw directrix as this line here. And then focal point is at 1.5, which is 3/2 above the vertex. So this is our vertex at 0, 0. This is our focal point here. And then you have your parabola, right, going like this. So this would be acceptable, I would say, because you have your vertex 0, 0. The equation for directrix is y equals to negative 3/2, and your focal point is at 0, 3/2, right? That's on top. The example for the sideways looks exactly the same, except now you are operating x in the x direction rather than up and down. So if you have that x is equal to, I don't know, 12y squared, right? And you are comparing that to x equals 4, yeah, x equals to 12y squared, sure. And then this is equal to, oh wait, I have it backwards. Y squared, so y squared is equal to 4px. Y squared is equal to 4px, there we go. Now, your y squared is equal to x over 12, so 4p is equal to 1 over 12, there we go. P equals to 1 over 48. And so let me see. Y squared is x over 12, so 4p is equal to 1 over 12. So p alone is, you multiply both sides by 1 over 4, so 1 over 48. Now that's going to be terrible to draw, but such is life. We have our sideways parabola. We have it centered at the 0. Again, that's our vertex. And 1 over 48. I'm just going to call that this line because it's, yeah, this is going to be now x equals negative 1 over 48. That's that line. And here is the focal point, F, with coordinates of positive 1 over 48, comma, 0 on y. And then you have your parabola going this. Now, this would be actually very skinny parabola with 1 over 48. It will look probably something like this, but it doesn't matter. We're not at negative 1 over 48. It's very close. Now let's shift this, and that will be it. So if you shift parabola, I just want to say shifts. Shift away from 0, 0. So we are introducing agent k now. So we're going to have y minus k squared is going to be 4px minus h. And we're also going to have x minus h squared to be 4py minus k. So these are our two. Our vertex is always going to be, for both of these, h comma k, because x is always with h, y is always with k, so vertex is always hk. The only thing you have to be careful is which way p goes when you get the problem, right? Which way to, like, maybe you have to do completing the square, maybe you have to do, so let's pick a homework problem and take a look at the details. So value for p is the only issue that we have. So let's see. Doesn't really matter. Problem 38 says x plus 2 squared is equal to negative 8 y plus 2. There we go. Okay, that matches that one, right? We have x squared. We'll do one with a y as well. I just want to have also maybe problem with the completing the square, so we have variety here. Anyway, so this is the problem that we have, and unfortunately it matches everything perfectly, so I can immediately pick off negative 2 for the vertex, and I can immediately pick up that p is equal to 2. I know that you would like to say, oh, it's negative 2, but p is the distance that will go one way and the other way, so you'll be adding it and subtracting it, so there is no need for a negative 2. P is a distance, so keep it positive. So 4p is equal to 8, p equals to 2. And when we draw, I will get the exact coordinates and points once we draw all of this. I'm going to put my x and y coordinate system, and then I'm going to go at negative 2, negative 2, and this is going to be my vertex v. Now, for since this is oriented up, right, because it's x squared, please remember this is very important, right? X squared, it opens up or down depending on a, and the y goes left to right. Now, what is your in this case, what is your a value? Is it positive or negative? It is negative, right? Because you have a big negative sign there. So this one will open downwards. That's important because remember, the one that opens downwards has a focal point inside and the directrix on top, right? Vertex is always in the middle. The one that we don't have now, which is opening up, has a directrix on the bottom and a focal point inside with the vertex in the middle. They're always aligned, right, like that, except they stack differently, whether it's opening up or opening down. So you just have to be careful about that. So what do I have? I have the vertex. Now I need to go 2 units up to draw directrix. Now that's going to be colliding with my x-axis because x-axis is 2 units up, right? So my directrix has the equation of y equal 0. And the focal point, f, will be 2 units downwards, f. And this thing is going to open down like this. Now, the focal points, you already have the vertex. So the focal points, f, is going to have the coordinates of negative 2, negative 4. And we have everything. We have the vertex, we have the directrix, and we have the focal point. Now, directrix has the equation, right? It's y equals 0. So please make sure that you write the equation. It is 2 units away. That's your P right there. It's 2 units away from the vertex. That's how we know where to draw. But it does have its equation, right? In this case, it was equal to 0. And let's take a look at one more problem. See if we can get some nice values from here. Problem 49 is y squared minus 4x plus 2y plus 21 equals to 0. So this is given practically in that standard form, and you are supposed to do the completing the square, right, to put it in the form that we use it, right? So y squared plus 2y plus 21 is equal to, and I'm going to kick 4x to the other side because if you take a look at your equations, it's y's on one side and x's on the other side. I don't care which one is squared, which one is not squared. It's just x's and y's are separated on different sides of the equal sign for a parabola. So that's the reason why I kicked 4x to the other side in this case. And now, when I group these first two and do the completing the square, right, we have the 2 divided by 2 squared, which gives us 1 squared, which is 1. We take 1 and we add and subtract to complete the square. And the first 3 give us completed square, square root of the first, sine of the second, square root of the third. And then you have that minus 1, but this time it multiplies by 1, so it stays negative 1. And you still have plus 21 equals to 4x. So you got your y plus 1 squared, and now equals to 4x minus 20. Now you can factor 4 on that side and get x minus 5. So if you carefully look at this, right, it matches y minus k squared is equal to 4p x minus h. So your k is negative 1, right? Because when you compare the two parentheses, you have y plus 1 and y minus k. See that? When you take off y, negative k is 1, which means k is negative 1. The other parenthesis says that h is equal to 5. Now it's important, remember how I made the mistake earlier, right? Put the h component first, because that's the x component, right? So our vertex is 5, negative 1. So 5, negative 1 for the vertex. We have that a is positive, and since this is a y squared case, for y squared case, it's sideways, but a positive opens to the right and a negative opens to the left. We have the top one, right? So I'm just going to erase the bottom one. So a is positive, and 4p equals to 4, so p is 1, right? So 4p equals to 4, 4p in front of h minus and this one, right? And p is equal to 1 from there. So we have enough information to draw this graph. There we go. Vertex is 5, negative 1. 1, 2, 3, 4, 5, negative 1. That's the vertex V. It's opening to the right, which means go 1 unit back to draw Directrix, because P is equal to 1. It's a 1 unit distance from vertex, and 1 unit to the right for focal point because it needs to be included in the parabola. So the last thing that I need is to find the focal point coordinates. That will be 6, -1, because it's just 1 unit away to the right. And there is the graph. We found everything. We have found the standard form. We have found the vertex. We have found the focal point, right? And we have the graph. P-value is not important. You don't circle or present P, right? P is just the number that helps you figure. Oh, I forgot to write the equation for the directrix. Directrix is equal to x equals 4, right? It's the vertical line through 4. That's 1, 2, 3, 4, and then 5 for the vertex and 6 for the focal point. So I forgot to. That's also something that you need to present as the answer. So we use the completing the square. This could be the best problem to study, right, for your preparation, because it has everything. It has completing the square, it has the standard form, it has the vertex and directrix and the focal point. It has everything in one problem. And the numbers lined up nicely, so we didn't have to deal with fractions like previous case, 1 over 48. Yeah, good luck with that. But again, that was the example that I, just came up with without too much thinking on or consideration for numbers. And yeah, that's it. Maybe I can do this. Would look a little bit better. That's the parabola. I hope you will practice, do all the homework, and bring your questions next class. Bye.